Right then, Houdini people. Here today I'm going to explain how I created the alien panel work example I did. Now if I click play here, you'll see as a quick recap of what it did. So this goes across and generates kind of a panel shape that you'll see sometimes embedded in walls, and sometimes they glow as well and you get this nice alien kind of pattern. So I click stop on that. And just to show you quickly how I lay my work out, I always do color coding because if I'm going to give my code or my scripts to someone else, I want them to be able to, get going as quick as possible. So I just have my input nodes, my outputs. The primaries are the ones which I go to most or the most important, and the secondaries are the ones that, don't really matter. And the utility is just, well, this one here is called display to save, and what I do is when I open up a scene, I don't want it to spend ages trying to load, so I just advise that you have an empty node and then you save, so then every time you open up the scene again, it's blank and it'll open up really quickly. Rather than, you having your output and it's got to load, this on opening the script. Cool, so I will start at the beginning again. So here I have my line of points. Now you can customize the length and the number of points here, but it doesn't really matter what you have. So I've gone for quite a small number so I can show you it generate quite quickly. I'm not looking at the right one. Solver, yep. So that's just 10 points with 100 height. And sorry, I just realized these two values here need to be the same with each other for the lines. Okay, because of the way I've got it set up. Now here I've got my group drivers, and these will be the points that are right on the end here that are going along, dropping down points as they go. And here are the places group, which are the ones that have been placed as these move along. Now I don't have to have these three nodes here, the null, the group, and the placer. I can just do it where the driver drops points into the places group, and then it will create the places group later. But I've left them here, so I've got a bit more, visual of what's going on at the beginning and what groups are going in. So if I click here, I'm just sending it to a points group, and this one here, I've got a placer point group, and then I merge them together. Right, so the next one is I want to create a set of attributes for my points, like seed, what lane they're currently traveling, what direction they're going to be traveling next, like which lane they're going to be switching to. Before I had an attribute create node here, but as you can see, it was a bit annoying that I had all these options going on when I just wanted a small collection of integers and floats. So I've put together a tiny subnet here, past attribute create, and it's just my own way of making, I just want to create some attributes. I don't want to have to write a massive story about what each attribute does and where they belong and who's their parents and everything. I just want to say, this is the name, this is the type. And this, all I've done is I've created, I can show you how I've done it. So a subnetwork is a good way to kind of, if you've got 50 nodes that all do something, you can stick them in a subnetwork and break, like the opposite of breaking out your layout, you're kind of condensing it into smaller parts, which is cool. So a subnet, and then inside here, I've got my attribute create nodes. So if I show you, if I go inside here, you can see it's rudimentary. It just has the inputs coming in, and then based on how many I've selected to be created, so my subnet currently supports up to 10 attributes, it will just go through and make them all for me. And I know it's a bit over the top, but at the same time, if I have 10 attributes here, you can see, look, it's just insane. All I want to do is just specify some attributes. And I'm not doing the default values here because I feel like it would be kind of hard coding them if you did them here. And I know you can go through and do them here, but I want to do them later in the solver with everything else and keep these as just, initializing them. Cool. And you can see here at the top of the subnet, it's got all these input options, and I didn't really want all this spam with my options. So what you do is you take your subnet, right click, and you can turn it into a digital asset, and then you can specify exactly the inputs that you want. So I turned all the inputs off apart from one, just so it can go through and then come out. Cool, so that's that. Now we can ignore this half for now. This is just aesthetics, doesn't matter. So our solver is the main thing we're going to dig into today. Let's go along and go inside. And you can see I've got my inputs, my special nodes, and my output, and not that special. And like I said before, a switch, what it'll do is I'll put frame equals 1. So on the first frame, it'll grab this node. So it's pretty much saying on the first frame, grab the initial input, but then from then on, grab the previous input. So it's kind of looping, which is cool. Next here, I've got a Python node. Now, normally I put this outside the scope of the solver, so around here. But then as that goes through, that will just generate a random number for me once. So by putting it in here, I'm generating random numbers per frame. Now, I know it's a bit overkill generating randoms here, but I'd like to just have constant regeneration of randoms to play with. So you can see here, this is only a tiny script, so I won't expand this like crazy. So I'm just saying, I'm bringing in random, and I'm saying for each point in the geo, I'm creating a lane seed. So what the lane seed is, I've got this point at the top, for example, it's going along, and when it becomes its time to switch, it has to choose, which lane it's going to be going to. So that lane seed helps me determine which lane I'm going to be going to. And I've put this Python node inside the solver, so it refreshes every frame, so then I can have, constantly making new decisions about which lane they're going to be going to, and I've always got a nice random seed to mess with. And delayed seed here, this is pretty similar. It's just how long will I stay going straight before I start to make a choice about switching lane. So that's the delay before the switch. And then here I'm just setting these two random numbers into my attributes here. And then finally, the values I've used in here, 1 to 1000, it doesn't really matter what values you use. I always try to stick with quite a wide range because I'm going to be plugging these into the random in the vex anyway. But I think 1 to 1000 has always served me well. So if I come out of that. Now going back to the top, I'll quickly explain what the attributes I've got here are before I dig into the vex. So the first one's called lane, and that will be which lane this driver is currently traveling in. So at the start, the lanes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then they'll switch. Lane seed is the random value that I'm constantly generating to decide, I'm going to use it, which lane I'm going to switch to. That's the seed value that's going to be used in the random. Next lane is going to be the next lane that I'm going to switch to. Switch delay is how long my point is going to wait and just keep moving forward before it's time to switch lane. So that's the delay. Switching is, there's no bools in vex, so I use these integers as bools as well. So switching is 0, 1, am I in the process of switching? If I am, I'm probably going diagonally. If I'm not, I'm probably going straight. Delay seed, same as lane seed, it just helps me generate a random number for how long I'm going to be delayed for before I switch lane. And then last but not least, setup, which is another int that I use as a bool, and that's just a value I like to use at the beginning of the solver. It's just setup will equal 0 by default. I can query it and say, are you 0? Yes, you are. Okay, you haven't been set up yet. Do some quick setup, set the setup to 1, and then it will never be run again. But I prefer that than hard coding some defaults into the attribute nodes to then have to go back and forth to change them all. So that's that. Right, and then we have a point wrangle node, which is where most of the fun happens. So you can see I've specified drivers here just so the places don't go through the loops and the motions. It will just be the drivers that get worked on. So let's bring this up. This is quite a small script, so I won't bother with Sublime today. It's just this long. So sometimes I try and break it down into functions if I can. Don't do it every time, just because sometimes it's more readable the way I've done it. So I have my functions here. I have my variables here. So I've got the min and max delay. So these delay values here are going to help me generate the number that's going to be the switch delay. Now I'm going to bring in the delay seed, and then I'm going to use these as like a range. And same for min and max lane here. Got some values here. So these are the ranges for my random number generation. And for this section here, I'll explain it quickly if I zoom in here. Now before I was having a problem where I was specifying the x width, so it was 1, but I was also specifying the z as 1. and they weren't the same lengths because one's diagonal. So what I had to use is a bit of trigonometry just to make sure that these are always the same length between them all. But it's pretty cool. So if I say speed is 0.1, so that's how far the points jump. And then here's my angle. I've specified degrees because I think it's easier to work with degrees than radians. So that'll be the angle at which it travels diagonally. And then my x and y speed is pretty much using that angle. I'm using trigonometry to give me, the point at which it can travel to still maintain that width this way, which is pretty cool. And then I'm using speed as a multiple on top of that. So that's the variables. So if we start going into the main, so this is the setup I was talking about, where this will just switch from 0 to 1 once, so I can set some like initial code. Now if you do Python, this is equivalent to in a class when you have an init function with stuff to do at the beginning. So like I said earlier, I don't like specifying defaults in different nodes outside, so I have to keep switching between this and other nodes. I like to have it all here, so it's all in one place. Now it would be even better to create a control node and just link up loads of attributes, so you don't even have to come in the code. Okay, so I've started off by assigning each point the lane that its ID is. So if this is point 1, then it starts in lane 1, which is pretty, which is a good starting point. Now you'll notice that the y and the lane are pretty much the same value. So why am I not using just y instead of lane? Now this is just to give me a bit more control over this value and to separate it out from the position value, because you never know, later on I might want to do something else to lane. Okay, so once I've assigned my point a lane, I'm then making sure that that point is actually in that lane, so I'm just setting the y value to that. And then to start off with, I'm saying next lane equals my current lane. So there was a glitch where it didn't like next lane being 0. So I've just started off by saying next lane equals this lane before I switch it. And then next is the switch delay. So this is the value, how long I'll wait before I then switch lane. Now if I show you how this works on a new lane quickly. So the first thing I'm doing, just type it out, delay seed. So the first thing I'm doing is I'm using my seed value that's getting generated to generate a random number. Now I could use this value here directly, but then I'd have to go back and forth to the Python nodes, changing the min and max range of that. So what I'm doing is I'm using that to bring into here to then generate a nice random number. And that's also so I don't put, frame or time or point number in here, because it's not really random, or it's not as random. But then, so this will give me a random value between 0 and 1, which is great, but then I then want to expand that out to encompass my min and max delay values I've got here. So what you can do is you can use the fit function to say, using this value, this is the old range, and I want to use the new range. So the range I'm specifying here is 0 to 10 to 100. So now I'm saying generate a random number and then fit that random number from its old range between 0 and 1 to 10 and 100. So it kind of spreads it out a bit, which is nice. And then on top of that, I'm just wrapping it in an int to change it from a float. Now I could use a float here, but I'm strictly using an int because it's traveling in time along the timeline, which is integers as well, down here 150. I just thought time is easier to manage if it's integers ticking up. And you can see here, just to make them a bit more readable and stand out, all my custom attributes are capital letters. Now, they're not really constants, but they are at the same time, so, don't worry about that. And also I don't have to use these letters here. I could just use @p, for example, which is the vector position in space of this point, but I'm putting v. I know it's a vector, but it's just, if I'm gonna add I to some things to get them to work, why don't I just, use all of them like this? And it makes them a bit more readable as well, so that's not really an issue. And then lastly, I'm saying setup equals to 1. So it's like, okay, everything's been done, it's all set up. This does not need to run more than once. Cool. So in this example, these points are always advancing in the X direction. So I'm saying move forward in the X position every frame. Now, even if this is switching lane and going to another one diagonally, it's still moving forward. So it's kind of a constant that it moves forward. So I've left that outside of any statements like ifs or functions. And then create point is also going to happen every frame without fail, because regardless, this current driver point is going to be moving away from its current position every time anyway. So just drop a point down. And this leaves me with 3 if statements, which I'll show you. Now I've tidied this code up and the node graph a bit for you. I mean, I'm sure there's better ways to do this and optimize this, but I just didn't want to give you guys my super messy network that I had at the beginning, because I just wanted to get an example working and then tidy up later. Okay, so the first if is if switch delay is not none. So what I'm saying is switch delay, when it hits 0, it's like a countdown timer, it switches lane. So here we say keep counting down if you're not 0, and then do nothing else. But then once it does hit 0, it triggers the switch. So down here it triggers the switch. It will say, okay, switch delay is now 0. Switching is always 0 because it doesn't switch at the beginning. So turn switching on and then generate a new number for my next lane. So I'm kind of saying, at the beginning of the switch, turn switching on and just get me really quickly the next lane I'm going to go to. Now I've done this after this so that it doesn't switch lane and then go and try and move it itself. It will set switching here to 1, and then on the next frame it will go through and it will start switching. So that's that one. And then the last one here is this will run every time it's moving diagonally, because moving forward is already done every time anyway here. So this bit isn't that complex. First off, I'm getting a lane difference between my current lane and where I'm traveling to. So then here in this if, I'm saying absolute lane difference. So then here, if it's like this lane in the middle, for example, and its next lane is going to be above it, the lane difference is going to be positive. But if the next lane is below it, then the lane difference is going to be negative. Now I don't really care whether it's positive or negative, I just want the distance between here and the next lane. So if I use absolute, it will change any value on the timeline to just the absolute value. So for example, 6 becomes 6, minus 6 becomes 6. So then I can use that as a measurement. And you can see I'm saying here, so the absolute value of lane difference, so just get me the measurement. And if it's smaller than the y speed, so the y speed here will be around 0.07. So then what that means is, because every time I jump forward in the y, I'm jumping forward by this y speed. Now if this actual distance of the y speed jump to the next position is actually bigger than the difference between the current point position and the next point, then I'm going to overshoot the lane and I'm going to have to go backwards on myself, which I don't want. So then pretty much saying if the jump to the next lane is actually smaller than the next jump value, I don't want to overshoot it. You might as well just set me to the next lane straight away. So I'm saying the current lane is now the next lane. I'm setting my position to be the next lane, and then I'm turning switching back to 0 because it's no longer traveling in the diagonal direction. And then switch delay, here I'm kind of resetting it back up to another value, so that will start counting down again and it will just start going through here. But now finally, if the lane difference is actually bigger and I can't make it to that next lane in just one jump, then this is the little section here where I'm just telling it to keep going regardless. So now direction, as my points are traveling to the next lane, they need to know whether it's up or down, whether it's going positive in the y or negative in the y. Now the best way I find to do this is to take my lane difference, so the measurement between the current lane and the one I need to go to, and if I divide that lane difference by the absolute of the lane difference, that will give me either 1 or minus 1. So that will be, am I going up or am I going down? So that's really cool. So I can easily now use that to say the y position of this point, just add this on, add on the speed, and by timesing it by direction, it will change the speed to negative or positive depending on whether I'm going up or down. And that will take care of changing my point from going up or going down. And then here I'm just saying set my current lane that I'm in back to my y value. Now again, you don't have to do this, but I like to do it so if I need to reference it later, I've got the lane rather than having to go into the .y. Yeah, so that's everything for the Vex code. I do hope I've not explained it too fast or too slow. Do let me know. If I click accept on here, I'll probably generate another one. Yep. So that was the nitty-gritty of the Vex code. So if we just click play here on the final result, we get this lovely cool changing panel motion. And it would be cool as well to loft these into points. There's the camera just flew by. And we can also, in the line, we can also upscale these values. Of course it will be slower, unfortunately, but you get a lot more detail in there. And I can show you what I mean by slower. I just change it to make it 100 high by 100 points. So of course by zooming out we immediately see more detail as well. Jeez, that's big. Okay, this is gonna be slow. Come on. Okay, so now that we've changed the height, and that is quite big for this, there is one little caveat that I haven't quite fixed yet. But in here, if you see the maximum lane, now this has to match the maximum number of lanes you've got going on here. At the moment you have to type it in. So this is now 100 instead of 10. Cool, so if I go back, just make sure 100, yeah, cool. And I click play. Oh, this is gonna take a while. Generate the random pattern. Unfortunately it's slow. I'm sure there's ways to make this faster. And there's just my other camera whizzing past. Hey, how you doing? Now this will be really cool if you just leave it and let it generate over 1,000 frames. It will look really nice. Although I don't really know if you'd need that much. I just think it looks nice if you just make it something lower, like 25 by 25. 25 there. Go back. Play. Now I am going to see if I can do some kind of cool stuff with this in the future. But that is how you generate some cool little random patterns. And just as a bonus, I will show you what I've done here with the bounds and the transforms. So you might be aware of the bend node. This helps things bend. So I was attempting to make it, instead of it going in a straight line, to have it generate in a swirl. So what I've done here is I've just made the bounds of all the points that are coming through. So the bounds of this. Let me let it generate for 200 frames-ish. Cool. And I get the bounds. And I've just transformed this to line up with my bend. Now this is me experimenting here. This is not really part of the tutorial anymore. And then you stick that into a lattice or a deformer node. And when this generates, get these lovely, cool circular generation. But I've already done a flip of this over 2,000 frames, which I'll show you now. Cool, so that's the tutorial. I hope that helped you guys out. I'll have a link to the Python and the Vex code in the description again. And yeah, I hope you find it useful, if it can help you out. And I hope you all have a good weekend. Bye!